All right, so if you could turn to page 14 of your packet, we're going to talk about solving fractional equations. And you can see, right at the top of the page, these are the steps that we're going to follow in order to solve the equations. All right, so let's start off by taking a look at number 32. Now, if you look at the first step says what we want to do is we want to find a common denominator. Okay, so if we have a 6, a 10, and a 15, if we were to list out a whole bunch of multiples of 6, right? 6, 12, 18, and so on, and a whole bunch of multiples of 10, and a whole bunch of multiples of 15, what we would see is that the lowest multiple that they have in common is 30. So what I'm going to do is I'm going to rewrite each of these fractions with a denominator of 30. We could make each of those original denominators into a 30. All right, so the first fraction, if you see the denominator is a 6. So in order to get a 6 to become a 30, we'd have to multiply it by 5. And you're allowed to multiply the denominator of a fraction by whatever number you want, as long as you do the same thing to the numerator. Okay, so in the denominator, 5 times 6 is 30. And in the numerator, we're going to take that 5 and distribute it to both terms. So 5 times x is 5x, and 5 times negative 4 is negative 20. So far, this is really just like the first step of what we do when we're adding or subtracting fractions. All right, so let's just continue on. What do we need to multiply 10 by to get us to a 30? Well, we need to multiply it by 3. So let's multiply the denominator as well as the numerator by 3. All right, so 3 times 10 gives us that 30 that we wanted, and let's distribute the top. 3 times x is 3x, and 3 times negative 2 is negative 6. And then our last fraction, we need to multiply the 15 by 2 to give us a 30, so we're going to do the same to the numerator as well. So then 2 times 31 is 62. All right, now that we've found our common denominators, if you look at the top of the page, at the second step, it says cross off the denominators. So once you have a common denominator, you could just cross them right off. We don't even, those are, they're not even necessary to help us solve for x. So step 3 says solve remaining numerators. So you're going to take the numerators that we have and just make them into one big equation and solve. All right, so let's first just combine our like terms. So 5x plus 3x is 8x. Negative 20 minus 6 is negative 26. I'll bring down the 62. All right, so since this is a first degree equation, we're just going to take our numbers and move them to one side of the equation. So I'm first going to add 26 to both sides of the equation, leaving me with 8x equals 88, and then just divide by 8. And when I do, I'm left with x equals 11. Now, if your original equation, if you had variables in the denominator here, so if you had x's in the denominators, what you'd want to do is you'd want to take your answer right here, 11, and substitute it back into the variables within your original denominators, and you'd want to make sure that it didn't create a 0 in any of the denominators. You'd want to make sure that it didn't make an undefined fraction, because if it did, we'd have to cross it off. All right, that might be a little confusing for this one because we don't have any variables in the denominator, so this is our answer, but you'll see when we get to our next problem. All right, so if you could turn to the next page, number 15, we're going to take a look at number 36. All right, so we're going to start this off the same. The first thing we want to do is we want to find a common denominator. Now, if you remember from, adding and subtracting fractions, if a denominator can be factored, you can do that first because a lot of times it helps you find a common denominator. So what I'm going to do is I'm going to factor this denominator right here to x times x minus 7. All right, so then it should be pretty apparent what the common denominator is going to be. Since this has the x minus 7, and so does this, and since this has an x, and so does this, we're going to need to include both of those in our common denominators. So I'm just going to rewrite some empty fraction bars here, get a little bigger. And I'm going to put an x times an x minus 7 in each of those denominators. So that's going to be our common denominator. All right, so let's look at the first fraction. What is this denominator missing that our common denominator has? Well, it's missing this x, right? It already has the x minus 7. It's just missing the x. So let's multiply the top and bottom by x. So x times x is x squared, and x times negative 3 is negative 3x. All right, then if we look at our second fraction, this one in the middle here, what is this denominator missing that our common denominator has? Well, it's missing this x minus 7. So let's put it there. And if we put it there, we have to also put it in the numerator. So 1 times x is 1x. You could just write x. And 1 times negative 7 is negative 7. And then this last fraction, it has the common denominator, so we don't even have to touch the numerator. We can just bring that 28 right down. Okay, so again, now we're on step 2, cross off the denominators. Since they're all the same, those don't really help us at all to solve our equation. What we need to do is we need to solve the remaining numerators. So I'm going to take this x squared minus 3x and bring it down. Now, be very careful here, okay? See this negative sign, this minus sign in front of the fraction? You want to make sure that you distribute that to both terms. So when we do, we're going to have a negative x, and a negative times a negative is a positive 7. Okay? Don't just bring down the negative and then bring down the x minus 7. Make sure you distribute that to both terms. And then bring down your equals 28. All right, now this time we have a quadratic equation, right? Our biggest exponent here is a 2. So when that happens, I think the easiest way to solve it is just to get this side of the equation set equal to 0, and then just factor and make a t-chart and solve. Or if it can't, be factored, then you'd have to use the quadratic formula. All right, so let's get this side of the equation, the right-hand side of the equation, set equal to 0. So there we go. I'm going to bring down my x squared. Negative 3x minus x would be negative 4x. And then positive 7 minus 28 would be negative 21. Okay, so now we could just factor, right? We can put an x and an x in the first spot in each parentheses, because this is your basic trinomial factoring. There's a 1 in front of our x squared. And you're just going to find two numbers that add to negative 4 and that multiply to negative 21. So negative 7 and positive 3. All right, so then if we make a t-chart and solve, we get x equals positive 7 and x equals negative 3. All right, so what we want to do is, since our original, before we circle those answers, since our original fractions, right, our original equation here had x's in the denominator, you want to go back and you want to make sure that if you were to substitute in either one of our two answers, it would not create an undefined fraction. So it wouldn't create a 0 in the denominator. So let's take this 7 and plug it in. If we take 7 and plug it in here, 7 minus 7 is 0. That fraction would be undefined. And even if you plugged it into this last one, 7 squared minus 7 times 7 is also 0. So this answer we cannot use. It creates an undefined fraction. And so just cross it off. And what this is called is, I'm going to try to fit it here, an extraneous root. Okay, this is an extraneous root. Even though we solved the equation correctly and that's what we got, if we plug it back in, it creates an undefined fraction, so we cannot use it. All right, if you take the negative 3, x equals negative 3, and substitute it in here, it doesn't create a 0. In this denominator, it doesn't create a 0. And in this denominator, it doesn't create a 0. So if you could say it doesn't create a 0 in any of the denominators, that would be a solution. And also, really what you should do is, if you want to check to make sure you did everything right, take the negative 3 and substitute it back into the original problem and see if it equals out. Okay, so if you turn to the next page in your packet, page 16, the last problem I'm going to do with you is number 38. All right, so in order to find a common denominator, we see this last fraction right here can be factored. So let's go ahead and factor it, because that usually helps us find a common denominator. So two numbers that multiply to negative 10 and add to positive 3 are positive 5 and negative 2. Now, if we look here, okay, we have an x plus 5, so does this. We have an x minus 2, and this is a 2 minus x. They're not exactly the same, okay? So you could do one of two things. You could either make your common denominator x plus 5 times x minus 2 times 2 minus x. You can include all three. But by doing that, you'll get the right answer in the end. It's just going to require a lot more work. The easy way to do it, if you remember, is if you have two terms, right, being subtracted in the opposite order, what's really happening is if you, let's say, factor out a -1 here, then really you're going to be left with a -2 and a positive x. So if you switch the order, x minus 2. So if you factor out a -1, this term right here is going to be exactly the same as this term. So what I'm going to do is I'm going to rewrite this as x minus 2. But since I factored out a -1, I have to take into account that negative somewhere. I could either just, put it up here with a 6. I could put it down here in parentheses. Or what I like to do is if I have a minus -1, isn't a minus negative the same thing as an addition? So I like to take this and change it to a plus sign. Okay, so really what I did was I switched the order here. I switch the order, and by doing so, I'm just taking this sign and I'm negating it. If it's a negative, I'm making it positive, and if it's a positive, I'm making it negative. Okay, so now let me rewrite my empty fraction bars. This time we have an addition sign in there, and we could see our common denominator is now going to be this x plus 5 and this x minus 2. So let me put that in each of the denominators. This is a little sloppy. All right, so let's just kind of go with the process we've been doing. So look at the first fraction. What is this denominator missing that our common denominator has? It's missing this x minus 2. So we'll multiply the numerator and the denominator by x minus 2. So that's going to leave us with 4x minus 8. Okay, the second fraction has the x minus 2, but it's missing this x plus 5 that our common denominator has. So I'm going to multiply the top and bottom by x plus 5. So if I distribute in the numerator, we'll have 6x plus 30. And then the last denominator has it all, so we're just going to bring down the numerator. Okay, if you recall, the next step once you find the common denominator is just to cross off those denominators. And step number 3 is to solve the remaining numerators. So this is a first degree equation, so I'm just going to combine my like terms, and then I'm going to move all the numbers to one side, and I'm going to get x all by itself. All right, so when I combine my like terms, I have 10x and then plus 22 equals 14. So now I want to move my numbers to the right-hand side of the equation. So I'm first going to subtract 22. And when I do, that gives me 10x equals -8. And then I'm going to divide by 10. So here I could either write this as a fraction in simplest form, so I could write this as -4/5. Or since it's a decimal that terminates, if I want to write it as -0.8, I can do that as well. All right, so now if I take this answer, -4/5, and plug it back in to these original denominators in place of x, it's not going to create a 0 anywhere. So it's not going to create any undefined fractions. So what that means is this is a valid solution. And if I want to check, I could just take it and substitute it back in to these original fractions and make sure that it checks. All right, so what I'd like you to do now is I'd like you to, I'm just kind of flipping back here. We skipped in our packet numbers 33, 34, 35, and 37. So I'd like you to try those 4 examples on your own, and then we'll go over them in class.